Mr. Donut's Awesome Math Network. It's the Awesome Math Network. Yeah. Math Network.
How do you get a tissue to dance? You put a little boogie in it. That's a good. You think I should use that one, right? Oh, I didn't see you guys there. Just working on some material to make these videos a little more interesting. Let's get that out of here. Welcome back to the Mr. Donut's Awesome Math Network. Today we're gonna build off our work with scale copies, and today's criteria for success. You will know you are successful if you can identify the corresponding parts of a figure and a scaled copy. So let's get right to it. So for our question of the day, we're here and being told that quadrilateral EFGH is a scaled copy of quadrilateral ABCD. Select all of the true statements. Well, we got a bunch of statements, and what they're looking to ask us is between these two figures, they say segment EF is twice as long as segment AB. Segment CD is twice as long as segment FG. The measure of angle HEF is twice the measure of angle DAB. And the length of segment EH is 16 units. Let's just enlargify that. A little enhancement here. A lot of words, a lot of statements. What we don't have are the, the quadrilaterals. Oh, you thought Mr. Donuts would leave you hanging? Here are the quadrilaterals. Let's zoom in a fire a little bit. Enhance. Okay, we've enhanced it. Okay, so right off the bat, in the directions, they told us that EFGH was a copy of ABCD, which makes ABCD the original. Or as they say in Spanish, el original. No. Oh, wow. Handwriting's getting a little bit better. And EFGH is the copy. Or as they say in English, the copy. Now, we go back to the original question, or the directions. They already told us that it's a scaled copy. There's no guesswork there. So because it's a copy, now what we can do is identify corresponding sides. And that is a word that I underlined. I made it red. I made it red in the criteria for success. Corresponding in math terms has to do with what it's basically like matching. So you have an original, ABCD, and you have the copy, EFGH. Notice how they have what's called the same orientation. They're facing the same way. And now what we can do is, what I'm going to do is I'm going to take this yellow highlighter and I'm going to highlight CD. You might be asking yourself, of all the segments to highlight, why that one? Well, the reason I highlighted CD is because, based on the fact that I know that the copy, EFGH, is a scaled copy of ABCD. CD and GH are corresponding sides. They also are the two sides that each have a number associated with them. And what I mean by that is, if you notice, the other three sides of EFGH do not have numbers. You might be asking, well, how do we figure those numbers out, Mr. Donuts? I'm going to tell you. We know that CD is 6, or has a value of 6, a measurement of 6, and we know that GH equals 12. We know that they're corresponding sides. They match, top. You want to keep it to simple terms of that nature. So now what we have to have... It's embarrassing. Are you plugged in? Are you plugged in? Oh, no! Might edit that out, might not. I don't know yet. Might delete later. So we have this plugged in, no more battery issues. So I hope that while I was jibber jabbering, that you asked yourself, well, what's the relationship? What's the relationship between 6 and 12? When we learned about scale factor in our previous video titled Scale Copies, we understand that to make a copy with a scale factor, the main operation we use is multiplication. So I ask you, what is the relationship? What is the multiplication relationship between the numbers 6 and 12? Now, if you said, well, Mr. Donis, 6 times 2 gives me 12, you are correct. Now, based on the evidence that we were given, based on the information that these are copies of each other, and looking at it, you can see that EFGH is bigger than the original. But we now are backing it up with actual data. And the data tells us that the scale factor, based on the corresponding sides, is 2. And in order for it to be a copy, all the sides have to be multiplied by 2. So what does that tell us? Well, over here, I'm going to thin it out just a little bit. BC is a copy of FG, which means we're going to take that number 4 and multiply by 2 as well. And 4 times 2 is 8. We're also going to do the same with our Tiffany blue side. Tiffany. 3. 3 times 2 is 6. Last but not least, our purple. Light purple. Purple. Oh, there we go. Nice. Is 8. And what's 8 times 2? 8 times 2 is 16. There you have it, folks. So we have, if you have colored pencils or crayons or highlighters at home, I find that math is a lot easier to see when you're labeling figures, and just a little bit more fun if you're able to color code items. So notice how I color coded the corresponding sides or the matching sides. Now we can go back and see what statements are true based on what we've done. Almost forgot. When we're making copies, the scale factor is 2 in this instance, for example. The exterior, the outside of the shape, is what is multiplied by 2. The interior, and by interior what I'm referencing, and this goes out to my 8th grade students or 8th graders out there, these angles measurements do not change. So if, for argument's sake, we say this corner angle is how many degrees, anybody? 90 degrees. Corner angle is 90 degrees. We're not multiplying 90 by 2 to get the angle over here of G. Even though C and G correspond, they're corresponding angles, which we'll get to in another lesson. Even though they're corresponding angles, we're not multiplying them by 2. If you multiply 90 by 2, you get 180. And all my geometry people out there, all my math folks, and my 8th graders, I hope, 180 degrees is a straight line. Does that look like a straight line to you? That's what I thought. Just keep that in mind when we go to our statements. So I'm going to erase this. I'm actually not going to erase it. I'm going to leave it there. Let's go back to our statements. Let's see. Segment EF is twice as long as AB. Let's see. EF is 6. AB is 3. 3 times 2 is 6. So this is true. Segment CD is twice as long as segment FG. Let's see. CD is twice as long as FG. Well, that can't be possible because the original image is smaller. So why would the segments of the smaller one be twice as big as the segments of the larger figure? So segment CD is not twice as long as FG. That's X. That's false. The measure of angle HEF is twice the measure of angle DAB. Well, we know that the angles are not multiplied by the scale factor. The angles correspond, they match, but they're not multiplied. So that is false. Last but not least, the length of segment EH is 16 units. Well, let's take a look. Well, what do you know? All this work we did at the beginning came into play. EH is, in fact, 16, so that last segment is true. So out of the 4 true 2 are true. True. 2 are true. And 2 are false. True. False. There you have it, my people. Thank you for tuning in. We'll be back with some more awesome math stuff on the Awesome Math Network. Special thanks to my sneaker of the lesson or sneaker of the day, depending on what day you're watching it, because it can't be sneaker of the day if you watch them all at once. And if you did that, that's cool. No judging here. My Air Jordan Shattered Backboard 3. I kind of just got these because I like shiny stuff, and people were kind of hating on them. And I was like, man, let's see if I can get them at a pretty good price. They're pretty fire. I don't wear them in the house because they're dirty on the bottom, you know. But I'll wear them outside when we go outside. And we will be going outside too. I just don't know when. But whenever that happens, make sure, whether you're inside or outside, you're smiling. I'm Mr. Dones. Peace out.
Mr. Dones, Awesome Math Network. It's the Awesome Math Network. Network, yeah, yeah. Math Network.